Hello, welcome back to Chapter 10, Section 1, Organizing and Displaying Data. In this final example, we're going to be deciding what type of graph to draw using the raw data. So there's a lot of overlap and there's a lot of decisions to make. And one of the things I mentioned in the previous video is I can put data in like Microsoft Excel or Google Sheets in like a spreadsheet software, and then a lot of this software will give me options for what kind of graph to draw, and a lot of them are really fancy because they're meant to be shown for like in business meetings, that kind of stuff, kind of beyond our purposes, where it's like, hey, let's just understand what it means first. In general though, here's the things that you need to look at, all right? And I'll write it down here. We'll talk about what to do with this one, but I'm gonna write it right here, okay? If you have categories, okay, so things are grouped together somehow, we're going to use a bar graph. Sometimes that category could be also group things based on time. But generally speaking, if you have time in minutes, hours, days, weeks, months, years, whatever, we want to see progress over time. We want to see if it changes from like minute to minute or from month to month. Then we're going to use a line graph. And if I have parts of a whole, then I'm going to use a circle graph. So let's look at this data and try to figure out which would be best for us, right? So we have livestock show entries. We have 38 chickens were put into this like county fair for the show. 10 goats, 32 horses, 12 pigs, and 25 sheep. Now, obviously I'm not using time. There's no time here, so this is not going to be a line graph, so I'm going to cross that one out. I'm not actually going to cross it out because I want to leave it there, right? But I'm going to like say I'm not going to do that one. So could it be a bar graph? Could it be a circle graph? Well, a circle graph means I have parts of a whole. If this is the total number of animals at this county fair, which it could very well be, it could be. But if this was the total number of animals, if no one putting, there's no cows, and I'm guessing there's probably going to be cows at a county fair. Maybe there might also be rabbits or geese. There's no geese. There's chicken, but there's no geese. I don't know if this is the entire like amount of animals that are shown at this county fair. If it was, I could probably show this as a circle graph. So it looks like chicken is the biggest number, so it would have the biggest part of the circle. And I could easily look at that circle and see, oh, there were more chickens than there were pigs, because it looks like pig would have, or goat would have the smallest parts of the circle. But again, I'm not quite sure about that, because what about the cows? What about the geese? I don't know. These are other animals that I've seen at county fairs. So it looks like the best way I could do this would be with a bar graph. Now what I want to do with the bar graph is I want to draw a line across the bottom, or if I want to turn on the side, I could do that. You saw that with this one. But I'll draw a line across the bottom, and I'll have the categories: the chicken, the goat, the horse, the pig, the sheep. And then I'll have a scale along one side. Actually, let me start drawing that. So I'm going to have a scale along the side where I'm not going to list these numbers. I don't want to do that. The biggest number is 38, so what I'll probably do is go 0, and then 10, then 20, then 30, then 40. And then I'll have chicken, goat, horse, pig, and sheep. And I'll draw my bar for the chicken, 38. That bar is going to go up almost to 40. For the goat, it's going to only go up to 10. For the horse, here's 30. It's going to go a little bit higher than 30. Pig, a little bit higher than 10. And sheep, it's going to be 25, about right there. Now, that's my sketch. I sketched it so I can have an idea of how to do it. What I really want to do is use graph paper. Maybe I need to use a ruler. Obviously, it looks like I kind of like lean this in. My boxes are not nice and pretty. But that's the idea behind it. Now, I did steal this picture from the book. Again, parts of it just are not coming through. I did steal this part of it. Oh, and instead of going by 10s, they're actually going by 8s. Hang on one second. I'm still here. Just got to make sure that while I'm doing this, I'm uploading stuff. Okay, so if I look at my scale, instead of going by 10s, it looks like they're going by 4s. 4, 8, 12, 16, 20, 24. This would have been 28, and this would have been 32. This would have been 36, and this would have been 40. So that's fine. Go by 10s, go by 5s, go by 4s, whatever. But the graph looks pretty much the same as what I had there, except they're using color. Getting to the same idea, let's look at this data. So now we have what part of the entire farm would be like these crops. That's what it means by division of acres. So in this case, we do have parts of a whole. So I'm thinking I'm going to use like a circle graph with this. This farmer has 70 plus 50, that's 120, that's 130, that's 170, that's 200 acres. So there's a total of 200 acres that this farmer has. 70 acres, about a third of it, is in corn. 50 of it is in fallow. Mixed vegetables, 10, you can read the rest of them. Since this represents parts of a whole, the whole being the entire farm, I can use a circle graph. Now, if I was going to draw this by hand, I mentioned in the circle graph, we usually don't draw these by hand anymore. But if I was going to draw it by hand, I'll show you the calculation that we would do. I'm going to grab my calculator. First, I'd take my part and divide it by my total. So I'd say 70 divided by 200. And then I would multiply, that's my fraction, I would multiply that by 360 degrees. So 70 divided by 200, and then I'd multiply that by 360 degrees, and I get 126. So when I draw my circle graph, and I'm just going to sketch it right here. When I draw my circle graph, using the center of my circle, I'm going to mark out about 126 degrees, and this would be corn. If my marker works. And one thing about that is I also need to show what the percent is. And since it's 0.35, that would be 35%. So 35% of the total acreage on this farm goes to corn. For fallow, and you can look it up what that is, 50 divided by 200 is 25, so that'd be, or 0.25, so that'd be 25%. If I multiply this by 360, I get 90 degrees. So then I would make a 90-degree angle from where I left off. And then I'd keep doing that for the rest of the stuff. 10 divided by 200, 40 divided by 200, etc. And I would end up with my circle graph something like this, okay, with mixed vegetables, soybeans, and wheat all in there. Obviously, I didn't draw it better. So this is the actual picture of what it looks like. And the only thing is if I turn it that way, I start out with like kind of a horizontal like that. Absolutely does not matter. Does not matter at all. You can rotate it wherever you want. But if you look at what I did here, okay, so I said corn was 35%. That's what we have here. Fallow was 25%. And if I kept figuring out the other ones, wheat would have been 15%, soybeans 20%, and the mixed vegetables are 5%. And that shows me the portions of the whole that are represented on this farm. Let's look at one more. You gotta be careful with that one. All right, how would I draw this graph? So Chinook College has enrollment. In the year 1930, they had 586 students. 1955, they really went up. They're at 2,361. 1980, 15,897. And 2005, 21,650. Would I use a bar graph for this? I absolutely could. I would draw my my big L shape. Across the bottom, I would have 1930, 1955, 1980, 2005. However, this kind of implies that we want to see the change from year to year, not just the categories. It doesn't say that. I said it implies that. So really, probably what I want to do instead is to draw a line graph. So again, I would have a vertical axis and a horizontal axis, and since I want to compare from time to time, from year to year, notice this is each of these is a 25-year difference. 30 plus 25 is 55, 55 plus 25 is 80, 80 plus 25 is 2005. So I would make sure that everything is equally or evenly spaced. So this would be 1930, 1955. I would use a ruler or graph paper to make sure this is all equal. This would be 1980, and again this would be 2005. I'm just sketching. And by the way, that's one of the things about drawing graphs. You're going to see this when we get to box and whisker plots and stem and leaf plots. Usually we sketch it and then we try to draw it a little bit better. My scale is going to go up to like over 20,000, so I don't think I want to start with 0, 1, 2, 3, 4, 5. Okay? Let's put this right here. Let's say this is 25,000. So if I kind of space it out equally, again, that's why a ruler or graph paper would be good. This looks like it'd be maybe 5,000, 10,000, 15,000, and 20,000. Another zero there. And in 1930, they had 586. That's like really way down here. That's not even 1,000 yet. That's more than half of 1,000. 1955, that'd be about right here. 15,000, it's almost 16,000. That would be, and again, if I had graph paper, it'd be better, about right there. And then 21,000 would be somewhere about right here. So it looks like my lines are going to do this. Again, that's my sketch, so I'm going to steal this. This is what the actual graph looks like, which kind of looks like mine. I had the right idea. That was obviously a little bit higher than it needed to be, but again, that's the idea. Okay, we'll see you in the next video.